Let's continue our previous lecture. We were talking on introduction to optical communication system. So in this lecture, we'll continue with that. We have discussed in the previous lecture about what the optical communication system is, what are different components, and in briefly, we have also seen a block diagram and tried to understand how advantageous the optical communication system is as compared to conventional copper wire communication system. So we'll just continue that lecture. You look at an interesting diagram here. You know, FTTN is nothing but fiber to the node. Fiber to the node. What is the importance of fiber to the node? Do we have optical fiber network in our house? Inside the house installation, is it done using fiber optic cable? It is not generally done. It is costly to replace all traditional copper wire networks with additional optical fiber support and infrastructure. The ISP provider, internet service provider, or service provider has a network of optical fibers in their area and that do not exactly go into the house. Near the house, it goes to one area from where they connect the, the connections inside the house. The last mile of many optical communication networks are usually copper wires, that is copper cables. And therefore you can look at here, the fiber is connected to the node. So there are different nodes in different areas and that node connects to different households. The node is connected to different houses, schools, colleges, or in college you can have nodes, you can have a fiber optic network, we have generally, and again that is distributed. And once it reaches to some place, fiber optic cable is connected to the node and the node distributes the signal inside the house. The kind of connection, this type of connection is called as FTTN, fiber to the node. Fiber to fiber, possible, but to the end users, generally nodes connect through normal wires, that is normal copper wires. The ISP, that is internet service providers, they provide optical connection to their consumers at doorsteps. They'll provide optical connection only. This kind of connection is called as, it's possible. It's not like that you cannot completely replace. It can be replaced and this is replaced. But the only thing which is involved is cost. So some service providers, they'll make it reach to the doorsteps, but the cost, the potential cost of the installation is, it becomes high, it becomes increased. And this kind of connection is called as fiber to the home. So the entire, this green color is a fiber actually, right? So from node to houses also, it is connecting with fiber. So everywhere fiber connection is there, and this system is called as FTTH. FTTH, that is fiber to the home. So there are two connections, fiber to the node, and from node, normal ordinary cables, and in fiber to the home, FTTH, all replaced by optical cables. Which one is costlier? Obviously, the costlier one is, which one? FTTH. The fiber optics versus copper wire. This is the gist, summary, advantages. What are the major advantages? Low transmission loss. In the previous lecture, we have explained, we have understood why the transmission loss is small, because the interference, possibility of interference, degradation, losses will be there, but interference is not there. What are different types of optical losses? Fiber losses, we'll study. Some degradation still happens around 0.2 dB per kilometer kind of signal degradation happens in optical communication also. But the transmission loss is low, interference is not there, electromagnetic interference is not there because of that low transmission loss. High bandwidth, we have already explained. which allows more data speed, more data rate, more number of customers. So therefore, everyone demands for high bandwidth for getting better, uh, you know, uh, uh, communication. And the next one is small size and weight. Small size and weight. Size is very small in optical communication. Weight very less as compared to copper wires. Immunity to interference. Immunity, because I think this also we have tried to understand in the previous lecture. Since in optical communication we have only what? Glasses. So glasses are not affected by interference, especially electromagnetic interference. So the system is immune to electromagnetic interference. Electrical isolation, there is nothing like electrical inside. So even if electrical connections and these things are there, the glasses, the media is isolated. So it provides you the extra isolation or insulation that always makes the system more safer to use. Signal security, the signal security is better, it is enhanced, more security is there in optical communication system as compared to the copper wire communication system. We'll also discuss the security aspect, the bandwidth considerations, the data losses, the degradation, the data rate, everything we'll discuss in detail. But this is the introductory lecture about introduction to optical communication system. So we are just highlighting what are the major points, what are the major advantages in optical communication. Abundant, the last point is abundant raw material. Abundant raw material. You know, raw material is what? Silica. Silica is the basic material. You know, the quartz is the main material used in the optical communication system. Silica is abundant, available abundant. But of course, some processing is needed. So there is no problem as far as the resources are concerned. The abundancy is there. There is no scarcity. So that is also there because copper wires, you know, you need more and more coppers to manufacture more you know, lengthy cables and wires. So that thing is overcome here. Next point is load. I mean, let's discuss all these advantages one by one briefly, because after this lecture we'll definitely have discussion on the advantages of optical communication system in detail. So more data can be sent over longer distances. It's because of two reasons. The heading is low transmission loss and higher bandwidth. So you can see in the first point, more data, longer distance. Why longer distance? Longer distance is because of low transmission loss. Because when signal is transmitted, the transmission media, during transmission, huge amount of losses occur, and therefore it cannot reach, it cannot travel to long distance. So if the transmission loss is low, obviously, if the transmission loss is low, what will happen? What will happen? It can reach, it can travel to longer distances. What is next point? Higher bandwidth. So higher bandwidth, as I have already explained, higher is the bandwidth, more is the data. I can explain you in a simple language. In the language of communication system, in terms of analog communication system, we define bandwidth in megahertz, kilohertz. What is megahertz? Mega samples per second, because ultimately your signal is transmitted in the form of samples. It can better be understood. You can easily understand in digital communication system. Bandwidth is defined in terms of Mbps, kbps, gbps. What is Mbps? Megabits per second. It's not megabytes. I have seen few people, they say that megabytes. It's not megabytes. Megabits per second. So you can understand bandwidth is represented in megabits per second. Data rate is represented, expressed in megabits per second. So the unit of data rate, the unit of bandwidth. So you can understand, more is the bandwidth, more number of megabytes and kilobytes or gigabytes per unit time can be transmitted. So what is the biggest advantage? The biggest advantage is more is the bandwidth, more data rate, more data rate. Less is the bandwidth, lesser data rate. And there is one more point, that more is the bandwidth, so we can accommodate more number of users as well, subscribers as well. When I talk in context with mobile communications, decrease number of wires and reduce number of repeaters. What is this? When you use optical cables, the length, the number of wires, so much of copper wires you install everywhere, right? Say like, web of wires inside the house or outside. When you use copper wire, you just imagine one telephone pole is there outside your home. There you find how much the messy it is, that copper wire, the which are there in the pole, and they're going to different houses. They're reaching to different houses. So decrease number of wires and reduce number of repeaters. What is this? We need to understand what is repeater. In my previous lecture, I have already explained you what is repeater. As its name suggests, repeater will be repeating again and again. So at certain interval, at certain distance, we need repeater. Why? Is to repeat the signal? No, the term is repeater, but is to strengthen the signal. So repeater is a kind of amplifier or series of amplifiers, combination of amplifiers, that may be cascade of amplifiers, cascade combination of amplifiers intended to strengthen, to boost, to increase the signal strength. So why? The signal strength is becoming very high, therefore the transmission loss is less. And for equal transmission loss or equal distance, the number of repeaters required in optical communication as compared to conventional communication system will be much lower. Reduce system cost and complexity. Of course, you understand. More wires, more complexity. More number of repeaters, more complexity. Hardware complexity, installation complexity, design complexity. The complexity will be high. And when you are increasing more number of wires, more number of repeaters, obviously the cost will also be high. But it's not like that. When you go for common use in the house, when you install the copper wires in your house, it will be less costly, but the lifespan will be not less. The service quality will not be good, will not be proper. So better is to go for, when you go for large scale applications, when you go for large scale implementations, it's always better. Which one? That is optical communication system. Reduced system cost and complexity. Small size and weight. You can imagine, you use a optical mouse and you just see that cable. What is the size and weight of the cable? It's not much. So when you compare a fiber optic cable with the copper cable, the size is less and weight is also smaller. It's not that much, bulky and heavy weight. Low weight and small size, air size dimensions also, fibers are their advantages for heavy bulk and the different applications. And therefore, because of small size and weight, it is preferably used in aircraft. Aircraft weight matters. Aircraft size matters. So it's used in aircraft, satellite communication, ships, due to small weight and size. Tactical military applications. Tactical military applications. Tactical military applications, these are the applications where the military deployment, they will use some setup of communication, a private network, possibly private network. They can directly communicate with their the head office or their commanding officer. There they need enhanced security and they can move it easily. So we'll discuss all about this in the next lectures. Implementing wirelessly you can implement a fiber optic cable and you can connect with wireless system, and and then you can communicate. So enhanced security is there, so therefore it is also used because of a small size of course and weight, but enhanced security is also there, that makes more useful in the applications like aircraft, satellite, tactical military applications, and other similar applications. The next point is immunity of interference. We also have, uh, discussed this. What are different types of interferences? Optical waveguides with immunity to EMI. What is EMI? It is your electromagnetic interference. So optical waveguides, we use the term waveguide. Waveguide is a media which guides the wave in optical communication as well as conventional communication signal. Signal travels in the form of wave. We call it as wave. So something which guides is waveguide. So waveguide with have immunity to EMI. Why? EMI, electromagnetic interference, will only interfere either magnetic signal or electrical signal or electromagnetic signal. But our signal is not like that, even though it's a signal which is traveling in the form of light, but it's not that. So such as inductive pickup. Inductive pickup is a term. Inductive pickup comes from the inductance term, magnetic term of EMI interference. Signal carrying through lightning effect also, some inductive pickup can be added and the interference can disturb. If lighting happens, your waveguide can disturb. See the second picture, free from electromagnetic pulse effect required in military applications. We cannot compromise on the quality of the signal. So therefore no immunity, no interference at all. High level of immunity is needed. So in military applications, electromagnetic pulse effect EMP is required. It must be free from these effects. So electromagnetic pulse effect EMI are caused by lightning, various, the effects in atmosphere, turbulences in atmosphere, perturbances in atmosphere, because of that. So in atmosphere, in the space you do not install, but if your cables are lying there, so but that interference, the lightning effect will definitely cause some problem in the cables wherever the cables are laid down. So the problem is, since it is not affected by electromagnetic signal, so therefore these pulses, these interferences will not disturb and the signal quality will be better. And therefore, due to enhanced signal quality and the enhanced signal security, it is used in military applications. Electrical isolation, we have already discussed. Electrical isolation. Glass material is there, which is insulator. Glass is a material which is insulator. So electrical isolation is there. So that, if you work with copper wire communication system, so there is no insulation, there is no isolation from electricity. So there is a risk of, electrical, that current. So that difficulty is not here in the optical communication system, because the glass, which is a material which is used. Secure communication is used in banking, computer network, military application. As I told you, security is very high. The signal is more secured in optical communication system, and therefore it is used in banking. You understand the application of network which is used in banking, how much security is required, a lot of financial data, financial transactions, financial usages of thousands of customers will be otherwise at stake if security is not there. Anyone can breach the security over the network and just manipulate the transactions and can do anything. So the computer network, wherever it is deployed in banking applications, optical cables are these days replacing, mostly in all developed and developing countries. This thing has already happened. And even if you go to rural villages, rural areas, optical cables are reaching there. Optical cables are, reaching into the villages. They're connecting to different nodes to facilitate the different, the benefits of ICT and the information technology. And the military application, of course, We have explained military application requires high secure data. No intruder can intrude your signal, which is intended for specific people. So therefore, it is used in military application. And this point was also, it came already in the previous slide. Abundant raw material. Abundant raw material is what? Silica is abundant, inexpensive. Take whatever amount, how much silica you want, you take it. But as I told you, it requires certain processing. Only expense is silica is abundant, but what is expense? What expense is involved? Only expense is in making the actual fiber process required to make ultra pure glass from raw material. Ultra pure glass from raw material. Very high quality of glass is needed. Remember, it's not like the mirror glass is, it can be used. If it is a mirror glass, there is a fiber optic cable you have seen in the optical mouse, which we use in your computer and laptop. You just, twist the cable, the glass will be broken. So you cannot do that. It must be of ultra pure, ultra high quality, very, very extremely high quality, very extremely pure glass is needed. So ultra pure glass is needed, and but that process requires some expenses. So this is all about the advantages, and in continuation with introduction to optical communication system. So let's sum up in 1 minute. In this lecture, we continued our previous lecture where we talked about introduction and importance of optical communication system. Here also we have continued our discussion with what are the components needed and the cables, the importance of cables, transmitters and receivers. And then we had some discussion about the major benefits, the major advantages of using optical communication, replacing the copper wire cables by the fiber optic cables. Of course, it has some challenges, it has some drawbacks, like the cost is a major factor, which we have also discussed in these lectures. Of course, when we go for large scale implementation, cost is also not a problem. And then we also discussed about two types of connectivity which are made, FTTN, that is fiber to the node, and then fiber to the home, FTTH. Fiber to the home is the connection where you can directly reach to the home, but it requires some cost. As I told you, if it is for large scale implementation, cost is not a factor because quality and security are much, much better as compared to conventional communication system in this optical communication. So that's all for today in this lecture.